Hi friends, today we're going to be working on the Unit 1, Day 3 notes. We're going to be looking at solving the absolute value inequalities. So with these examples, one of the things to know is that there's with less than and greater than, that there are inequalities that go with these. When we talk about the absolute value, this is basically deciding whether it is an and or an or problem. So talking about the steps to solve over here. When we have a less than, or a less than or equal to, then we call this an and inequality. And then we have a greater, or a greater than or equal to, we call that an or inequality. And one of the ways that you can use to remember that, mnemonic I learned from Miss Thompson actually, is that she calls it the less than, and then the great or. So, pardon my spelling, that's to help you remember. So jumping into now number 4, solving this, knowing that this is a less than inequality, we're going to be following the less than rules for as we solve this. One of the things I want to do first is isolate the absolute value. So we're going to multiply both sides by 4. So I get the absolute value of 3x plus 2 is less than or equal to 4. And now, knowing that we're going to apply the direction, we're talking about distance. This talks about distance. When we apply the negative direction, you need to remember that we have to flip the inequality because we're applying the negative direction. We're changing the direction of this. We have to change the direction of the inequality symbol. It does not change that this is a less than because we always look to the original to see which situation we're working with here. And then we'll also solve 3x plus 2 is less than or equal to 4. So we have these two scenarios, minus 2 on both sides. So we get 3x is greater than or equal to negative 6. Divide by 3 on both sides, and we get x is greater than or equal to negative 2. So that's one scenario. And then the other one, let's see, we're going to subtract 2 on both sides. So we get 3x is less than or equal to 2. Divide by 3. And we get x is less than or equal to 2/3. Now, this scenario is an and scenario. So if I think about this, when I'm graphing this or I'm talking about a solution on a number line or an interval, has to be within both of these. So it says write it in interval notation. So if it's interval, looks like we're including these values. So we're going from negative 2 to 2/3 inclusive. Note that in these scenarios or situations, if it's going to be inclusive, it's inclusive for both, because it starts out with equal to. If it's not going to be inclusive, so it's just going to be a less than, then it would be not inclusive for both. So no matter which way, you have that. And then set notation, the set of x such that, so we have x is between negative 2 inclusive and 2/3 inclusive. And then if I was to write this on a number line, we would have negative 2, 2/3, filled in dots, and then shaded in towards the middle. That's for number 4. Number 5. This is a less than as well. It's already set up. We just need to separate it into the two parts. So I'm going to have 2x minus 7 is greater than, in this case, positive 5. And then 2x minus 7 is less than negative 5. Some of you may have already caught on to what's happening with this problem. Bear with me. I'm actually going to work through this problem so we can see what's really happening here. So let's see. If I add 7 on both sides here, I get 2x is greater than 12, divide by 2, and I get x is greater than 6, and, now remember, and, this is an and. Let's see, add 7 on both sides. 2x is less than 2, so I get x is, divide by 2 on both sides. X is less than 1. Wait, and x is less than 1. How can I be greater than 6 and less than 1 at the same time? So whenever you see an absolute value by itself and then there's a relationship going on with negatives, in this scenario, it's impossible. There's no solution set. The solution set for this is empty. The null set. There's nothing there. You could put either. And then the interval for this. There's no interval. X is not part of the solution set. There's no solution. And that's because, again, distance, we can't have distance being less than a negative number. You can't be less than a negative number. You can't have distance being negative at all. So for this one, just note that. So this is kind of one scenario. There's another special case we're going to see soon. Not that soon. Some of you are jumping to the next problem. No. Don't worry. We got this. Because we have to just get the absolute value by itself. A lot of students will jump into, oh, well, it's negative over there right away. Don't fall into that it's negative over there right away trap. Actually go through and get the absolute value by itself. It deserves to have a chance. If I multiply by the reciprocal, I'm going to multiply by negative 3 on both sides. Remember, when you multiply by the reciprocal, we need to flip the inequality because of negative. So I'm left with 3 plus x over 2 is greater than 6. Now that we have a positive sign, we can actually go through and solve this. This is also going to be a greater than, so this will help with setting it up. So I'm going to have 3 plus x over 2 is less than negative 6. And 3, make this 3 a little bit bigger. 3 plus x over 2 is greater than 6. All right, minus 3 on both sides. I get x over 2 is less than negative 9. Minus 3 on both sides. I get x over 2 is greater than 3. Multiply by 2. So I'm going to have x is less than negative 18, or multiply by 2, or x is greater than 6. Now this is an or situation, so this is a valid thing. I could be from negative infinity to negative 18, non-inclusive, union, non-inclusive 6 to infinity. That's perfectly fine. That is okay to have that. The set of x such that x is less than negative 18 or x is greater than 6. And then on the number line, negative 18, 6, shading this way, shading this way. There we go. Number 7. So again, this is very similar to number 2, talking about the absolute value. The absolute value, the distance has to be greater than or equal to any negative number. So if we think about this, if I think about this in terms of what we're talking about, the distance has to be greater than any negative number, which means it can also be 0. If it can be greater than any negative number, 0 inclusive, the distance, whatever value, whatever number you plug in, is going to be true. Think about this, no matter what number or value you plug in, you're always going to be greater than or equal to, you're going to be greater than negative 3 halves. So, kind of thinking about this in terms of what's going on, since distance is non-negative, no matter what value we plug in, this is going to be true. So my solution set for this is going to be from negative infinity to infinity. And in set notation, the set of x such that x is an element of the real numbers. No matter what value you pick, it works. You can verify that this is in fact correct by working through and getting a situation where you're greater than, or great or any number you want, and you get that. Join me in the next video as we go over the last example with a word problem.